Today I want to look at making a circular menu like this that can dynamically have more or less entries in it. I've seen a lot of these circular menus where it's hard-coded, whether you have 3, 4, 5, 6 different segments, but nothing really that lets you just add more as you need them. So these will be selectable by cursor, as you would expect, but if I move over to my controller, using the right analog stick, I can also go between them. Right now it's not very obvious which one is selected, but that's all adjustable. So we'll take a look into that. And just to show you, we have a widget here with a circular menu, and we just have an array of menu items. In this case, those are just textures to show you how it works. And as I add more elements to this, you can see that it replaces everything into the proper positions, and I can change the size of each individual image as I need. So if I need them to be a lot smaller because I have a bunch of extra stuff, I can do that. So let's get into how to make this. We're here in an entirely empty new project. If you want the project files to mess around with, there's a link down below in the description for Patreons and YouTube members, as always. So let's get into working on this menu. There's a couple of things of setup that we need to take a look at. So I'm going to go into the top-down input mappings that we have. Let's open up the input mappings. And let's also go into the input actions. We're going to make a new input action here. So we can just look for inputs action. And we'll call this something like IA menu picker. Opening that up, we'll make sure that we can trigger this while it's paused, because if we open up a menu, there's a good chance that our game is going to be paused. And then the value type, we're going to set to being a vector 2D, because we want to be able to get what direction we're pointing in, and we're going to convert that to an angle and do a lot of like fancy math. But the input is going to be a two-dimensional axis, a up axis and a left to right axis. So with that action made, we can go into our mappings and add a mapping for that, which input action menu picker will simply be the right thumbstick, and make sure to pick the 2D axis, not the x-axis, not the y-axis. We're going to pick the 2D axis. And that's all we need to do for that for the time being. We're not going to be using that for a while to go, but I wanted to set this up right away so that we have that to work with. Next up, let's make the widgets that we're going to be working with. So we're going to make 3 widgets. One widget that we actually add to the screen, one widget for the actual Radial menu itself, and then one widget for the Radial menu button that we're going to be working with. So let's set up user interface, widget blueprint, and let's go from bottom to top. So we're going to make the button first, then we'll make the Radial menu, which has pretty much all the work in it, and then we'll make an actual widget to add to the screen to put that Radial menu inside. So this will be the widget blueprint menu button. And that's going to be fairly easy, because that's just going to be a button, which we can just drag and drop in. And that button is going to have an image on it. And that's really everything there is to it. We want to set that image to filling horizontally and vertically. I personally don't give it any padding. And then we want to set this color and opacity to being whatever color tint you want to apply when something is not selected. So in my example, I set that to about 50% gray. Let's go a little darker. Let's go about 15 instead. So 15% in brightness, so that it's nice and dark when we don't have this selected. And we'll copy over that hex code. In this case, that is 262626FF. We'll want to go into the button as well. And there we want to change the background color for the button. The alpha is going to be 0, so that the button itself isn't visible. We just use the button to drive things like clickability and hovering and unhovering, so that we can update the image itself. You can just do that within the button if you really wanted to. I prefer doing it this way because it's a little bit easier to set up. Let's go into the event graph now though. With the button selected, we can add the onHover and onUnhover events. And for those, we're going to grab the image, and there we will set color and opacity for both of them. And we'll hook those up to the corresponding events to do with the button. And when we unhover it, so when we are no longer selecting this, we're going to set the color and opacity to the same tints that we just applied for like the default unselected state. And that will, in our case, be 262626 FF, which is about 15% on all three channels. Then when we do have them selected, so when we are hovering over them, I'm going to set it to just full white so that you see the image in all of its full color. Now, this works for mouse and keyboard. If we're using a controller, you don't really hover because you don't really have a cursor with mouse and keyboard. So instead what we're going to do is we'll add a event. Let's start with the hover event on added to focus path. So when this thing gets focus on it, we'll do the same thing as when we hover over it. And then we can also, for the other one, on remove from focus path, then it is no longer selected. So this is how you set up the colors for those images. Now how to set up the image itself. We do that in event pre-construct. So let's get our image and we set the brush for this image from a texture. And that texture was simply going to promote to a variable. We can just call that texture, that's fine. We make that exposed, instance editable, and we expose it on spawn. So that when we create a widget of this type, we can give in what it should look like. And that is everything to do with the menu button. So it's pretty straightforward. Now let's get into the fun stuff. And that is the actual Radial menu itself. So let's make another user widget, widget blueprint. And we'll call that WBP Radial menu. And here we will add just a canvas panel, nothing more. There is something to be said about the fact that using too many canvas panels in a UI is suboptimal because it does take some more processing power to draw a canvas because it's a lot more complex. But setting up the positioning of all these things on a canvas panel is a lot less of a headache than it would be on something like an overlay, which might be slightly more performant, but doesn't allow you to as easily set direct positions for widget elements. And since we are going to need to pretty directly set the positions of our elements because we're doing this like radial positioning, using a canvas panel here is just a lot more user-friendly for you. And as long as you don't go throwing like dozens of these around on your other widgets, you will not actually see any difference in like performance or anything. Anyway, with that disclaimer out of the way, make sure that the canvas panel is selected and we set it to is variable because we're going to be dynamically adding stuff to it. And then we can immediately move into the event graph because there's nothing that we actually need to set up in the designer for this. This is all going to be code. And we're going to be working in event pre-construct here, mostly. So I want to add a couple of variables as we start right away. The first one will be the radius, which will be a float, and we're going to be exposing that because we want to set that on an individual instance basis. Then I also want to add the image size, which is going to be a vector 2D, also exposed because I want to be able to, again, set how big each image is on each Radial menu. And then I'm also going to set the menu items, which is going to be the array that will actually display the menu items that we're going to be adding. This, at the moment, will just make a texture 2D, and we're going to make that into an array. If you have like anything else, like maybe an inventory system that has inventory like items, and you can take like images from that, and you want to display like a favorites menu of your favorite items in your game or whatever, you can of course make this menu item array any type that you want. For now, it's just going to be images, but this is expandable into whatever type your game might require. And then we're going to do one more thing, and that is adding another array of items. You can call this whatever you want. This might not be the most descriptive thing. And instead of making those the textures, that's going to be our menu button that we just made, because we want to keep track of those menu buttons as we add them so that we can either access them or remove them when need be. That doesn't need to be exposed though. That's just internal use for the blueprint itself. With those added, we can go into event pre-construct and we get our items array, so the one with the menu buttons in it. And the first thing we do is clear, because anytime we run this, we want to make sure that we start with an empty array so that we can add new stuff to it. Same thing with our canvas panel here. We want to clear its children so that it's entirely empty before we start adding new stuff to it. Then we get our menu items. So this is going to be, in our case, the textures or the items that you want to add into it from your inventory or your option menu if you want to make it do that or whatever. And we're going to for each loop over that. Because for each menu item, we want to add a button. So let's do that and create a widget of our type WBP menu button, which takes in a texture. Well, our menu item array is an array of textures, so we can just supply that in right away. Again, if you're using like items or whatever from either like a data table or a data asset, you'll need to get the texture out of your item struct or data asset or again, whatever, to put it in here. That creates a widget. Now we need to add that to our canvas panel. So let's get our canvas panel again, and we can add a child. And the content we're going to be adding will be the widget that we just created. And now we should be able to see if we go back in here and we select the Radial menu itself, we have our menu items. And if I add one, you can see it adds a gray little box, which isn't in the place that we want it to be. It doesn't do anything yet, but there is a gray little box, and that's all we care about. So for now, let's actually just like add 5 of them. So that when we come back here, we can always see like how they're laid out and what they're doing. After adding that child, we get a generic panel slot reference, and that doesn't really give us what we needed to do. So we need to cast that to the canvas panel slot so that we can properly set its position and its anchoring and all that kind of stuff. So with that, let's start by setting the anchors for it. So set anchors, and there we can split the structure pin, and then we get the in minimum and in maximum. And for both of those, that's just going to be 0.5 all the way through. So it's going to be the exact middle of the screen. It doesn't do any weird scaling, because the scaling that we do, we base on the radius variable instead. That does mean that on weird aspect ratios and weird resolutions, the menu might behave a little bit strangely at times. But the thing is, you really don't want a radial menu to start like being pushed around, because then it's no longer a circle. So do keep that in mind as you add these into your other widgets, that you might want to like not make them very big and full screen. Add a little bit of margin to all these sides, so that if somebody's playing on a slightly different aspect ratio, it doesn't cut off anything. After setting the anchors, we want to set the alignment, which also is going to be 0.5.5, because we want to align every single position to the middle of the button and the image. And then we're going to be setting its size. And for setting the size, we just get our image size variable that we made, which we should give a default value. So let's give that a default value of 100 by 100. And that will set the size of everything. So now if we go back, we'll see that everything has moved to the middle. It's not quite a square, and that is because there's a little bit of margin in there, and that's just kind of what happens with a button, because you can see all of our padding is set to 0. So that is less than ideal maybe. But you can just mess around a little bit with the size to get them looking the way you want them to look. And now we get to the fun bit, and that is we're going to set the position. And this is effectively just the offset position from the center point, from the anchor point that we made, which is the center of this widget. Setting the position is going to involve a little bit of math. So bear with me, we're going to go through this. This has a lot of like trigonometry and working with like radians and stuff like that. Which can be a bit mind-melting at times for a lot of people, but we're going to go through it one step at a time. So the very first thing to do is just splitting this into an X and a Y position so that we can individually calculate these easily. And let's get started by just doing the X, and then we'll do the Y afterwards. And I'm actually going to set this up in its own little sub-function to just make things a little bit easier. So let's just right click on this node, and we can collapse this to function, and this will be set item position. And if we double click, we open that up as the function. So we'll give this input a better name, something like widget. Well, it's actually the canvas panel slot, but we'll call it widget, that's fine. And in there, what we're going to do is we need to know what amount of degrees should be between every single entry slot, right? Because if we have 4 different entries, everyone should be 90 degrees offset from the last. But if we have 30, everyone should be like 10 point something degrees offset from the last. So the more we have, the smaller that angle will be. So before we do anything else, we need to know that. So for that, we actually want to go back out here because that's going to stay consistent throughout the entire thing. So at the very start here, even before doing any of this stuff, I would say, let's make a new variable, and that will be the angle difference for every single one of these, which is going to be a float. We're going to set that angle difference, and the angle difference is going to be fairly easy to calculate because it will just be 360, a full circle, divided by the amount of entries that we have. So we can set this with a division node of 360, and then we simply just get our menu items. We get the length of that to see how many items are in it, and then we make that into a float, because otherwise the division node is going to freak out. And we have our angle difference. This is the angle between every single one of the entries. Back in our set item position, what we want to do is now we need to get the index of whatever we're working with. So for the first one, that's going to be 0. For the second one, that's going to be 1. For the third one, that's going to be 2. And we're going to multiply that angle difference with that index so that we get the angle that this thing should physically be at in our widget. So let's make that an input here. We'll call that just index, and we'll set that to being an integer. Here we'll make a local variable, and this will be the element angle, the angle that the element is going to be set at, and we'll make that our angle difference multiplied by the index that we have. This gets us the angle that we should be at in degrees, but with programming and with like code in general, working with degrees is a bit of a pain in a lot of scenarios. So we tend to convert our degrees to radians instead because computers are just better at working with those. So we then take this and we do a degree to radians so that we can start working with radians. I think you can set this thing up entirely to use only degrees if you really want to, because Blueprint has, we're going to be using like sine and cosine, and it has a degree version and a radian version. So you might be able to get away with just using degrees, but I'm sticking with radians because we're going to need to multiply and like add stuff together, and I'm not entirely sure how that's going to interact if you're just using degrees directly. Anyway, now that we have the angle that we should be at set up, we can start populating the x and the y. So both of those are going to come from an addition node. And the things that we're going to be adding will be, in this case, 0.5, because we want to get the 0.5 position, the middle position of our widget as the base. And then we're going to be adding the radius multiplied by the cosine of our degree to radians. So make sure that you pick cosine radians and multiply that and then add it together and set that as the x input position. For the y input position, it's actually fairly simple as well. We just add an addition as well, 0.5, and instead of multiplying the radius by cosine, for the y position, what we do is we get that angle and we multiply it by a sine. So again, make sure to pick the radian version, multiply it by the radius, add it to 0.5, make sure to hook up the execution as well. And that's pretty much everything to setting position. So the element angle being a local variable is the reason that I wanted to make this into its own little function. And also to prevent things from being like a little too noodly in the main event graph. So now it's just like one little node where we do need to hook up the index to the index of the for each loop. And after that, it's as simple as just taking our items array, the menu buttons array that we made, and adding the thing that we just created. So create menu button. Take that and drag it all the way over in here so that that now also has that in its array. Let's also set the radius up to have a default value of like 350 or something like that. You'll see if we go into the designer now, we have these things in a radial position. But you might be saying, hey, that seems off, that doesn't seem right. And the reason for that is that it starts at the right position and adds them circularly like this. And that's not how you intuitively would make this. How you intuitively would make a circle is usually starting at the top, right? So you can see if I remove all of these menu items, and I just add one, it adds one here, and then the next one it adds there. And if I keep adding them, you can see it adds them radially like this. Or actually it adds them like this, I believe, in the other direction. So if we go back into set item position, before turning our element angle into the radians, what we're going to do is we're just going to subtract 90 from it. And actually looking at all this, there's no real reason to make that a local variable. So we can just kind of like get rid of that and just make it do all this. A local variable, honestly, is just there to give you a little bit of a better understanding of what's going on. But functionally, just having them all in like math nodes like this will work fine. And now it starts at the top. So if I again remove all of these, you can see it starts adding them in a way that is a little bit more. So now we've made these, but we need to make them selectable as well, right? That's part of the whole idea. And if we add this to the level, so let's just do that real quick. Open blueprint level. On begin play, we will create a widget for which we actually need a widget to have that thing in. So let's just make a widget that we can add to the screen real quick. So widget blueprint, user widget, WBP screen widget is what I would call this, just for testing purposes right now. It's going to have a canvas panel. So this way you have two canvas panels on screen at the same time. Not ideal, also not a huge issue. Then we'll add the radial menu that we created. We can anchor that to the center and then just simply set the X and Y position to 0 and the alignment to 0.5 and 0.5. It might be good to like size this up still to encompass pretty much like the entire size of the thing. Shouldn't be necessary, I think, because this is not really going to scale with the screen too much anyway. But we have this set up now, and let's add some images to this one. So we can add these images just like I had before. So back in the level blueprint, we can now create that widget, add it to the viewport. And I'm also going to immediately just pause the game because I don't want the camera to like start doing weird stuff as we're testing this out. So now we start the game and we can like immediately see that this works. As I hover over these, they get properly selected and everything works perfectly fine. But my controller doesn't do anything yet. So that's the next tricky bit that's going to involve a little bit of math. Going back into the radio menu, here we can add a input action for our menu picker, the one that we made at the very beginning of the video. And we're going to need to use this action value to get the degree at which the sticker steals it and then compare it to every single entry and see which one is the closest. It's a little bit annoying to do, but we'll go through it one step at a time. So before we do anything else, we want to check this and we want to check if it is nearly 0, just so that we don't accidentally and unnecessarily spam this. So only if it is not nearly 0 will we actually like do anything here. And what we will do is we will actually make a new function for this as well. And we'll call this pick item by controller. And that's going to have just the input value there. So this will be the input value, which will be a vector 2D, because it's going to be an X and a Y axis. And it's going to output a element that we're going to be focusing on. So this will output the button that we want to focus on, and that will be of type WBP menu button. Now, how do we get that? That's the question, isn't it? And the answer will be a bunch of math and a bunch of local variables. So I think we're going to make a bunch of the variables to begin with so that we have it all set up and we can start working. So what do we need? We need to have the step angle or the angle difference between every single one of these. Luckily, we already have that in a global variable that we have here. Then we need an integer for the best index. That's the index that we're going to be picking. So that can be a local variable because that's only relevant to this function itself. So we can call it best index. It will be an integer. Then we need to keep track of the smallest difference that we so far have found. So let's call this smallest diff between the current angle that we have and any of the buttons. So the smallest difference by default, if we haven't found anything yet, is going to be 360, so that anything we find after it immediately will qualify as the smallest difference. And from that point onward, it will all compare to that. Then we need the element angle. That is the angle of the elements that we are currently comparing against. So that's going to be different for each and every single one of the buttons. And then we need the input angle, which is going to be the angle that this input vector 2D represents. So let's get started by populating the input angle, because I think that is the most important one. So let's set that. And the way we get that is we get our vector 2D inputs and we break that into its individual components. And then we get a tan 2 in degrees. And here you need to pay some attention, because you might be tempted to just plug this into there and just call it a day. But the x and the y are actually flipped around. So the top one in the break vector is the x, but the bottom one is the x for the a10 node. So you need to like cross them like this. Then, just to be sure that we're working with a range of 0 to 360, we need to do a little bit of extra stuff, because this a10 node actually gives you a range of 180 to minus 180. So we need to kind of like bump that up into the 0 to 360 range. So what we'll do is we'll check if any of these are less than 0. And based on that, we're going to either pick the original value or the original value plus 360. So let's use a select float node for that. So if this is not less than 0, it is a positive number, so we can just pick the value itself, and otherwise we pick the value with 360 added to it. You could just add 180 to everything, and that would essentially do the same thing. But that might sometimes get a little iffy with things that are very near the 0 to 360 cutoff wraparound line. So that's the reason that I like doing it this way. So now we have our input angle. So from there we get our items array. So these are the menu buttons, not the textual one, but the one that we procedurally populated in the event graph within our other for each loop here. So the one that we're adding items to, that one. And we're going to be for each looping over that in here as well. And there we can set the element angle. So let's get our local variables again. Element angle is what we're going to be calculating now. So here we get the angle diff, which I'm actually going to rename to step angle, because it's a little bit more descriptive. And I think we do need another local variable here in a moment. That's actually the difference between the two angles. So the name angle diff is more descriptive and less confusing to use for that. And just like we did before, we use that step angle and multiply it by the index to figure out, hey, what is the angle for this element? And we will subtract 90 from it, because we did that before as well. And we're going to set that to be the element angle. Again, a lot of these local variables aren't necessarily needed to use. They just make things a little bit more readable and a little less confusing with like lines all over the place. Then we want to set the angle diff. So this is what I was talking about before. We want to set a local variable here to keep track of what is the difference between our input angle and that element angle. So we get that, put that in there. And the way we calculate that is we get the element angle, which we just set, and the input angle, which we set before the for each loop, and we subtract those from each other. So we go element angle minus input angle, and then a little bit of funky math. We add to that 540, and then we use the division node, but not just divide. We want to divide whole and remainder, and we want to divide it by 360, because the only thing that we really care about is the remainder of this. And from that remainder, we're going to subtract another 100. And from that, we want to get the absolute value. And that will be our angle difference. Is this a funky little bit of math? Welcome to trigonometry. None of it makes sense. This will get you the angle difference. And that's all that's important to talk about right now. So then we check if that angle difference is less than our smallest difference that we have found so far, which again, the default value will be 306. And if it is, what we'll do, this return I can actually just go away, because we don't need to hook that up yet. If it is, so if our angle difference is smaller than the smallest difference that we have found so far, first thing that we do is we set our smallest difference to whatever that angle we just found is, so that the next time around we're comparing to that instead of 360, or whatever the last one was. And then we set the best index that we have found to being the index that we're currently on for each loop. And that is how we loop over this time after time after time again. And at the end of it, we'll have an integer value that we can use on our items array to get a copy to the thing that we actually want to select. So after we complete the for each loop, that is when we return. And we return the best index that we have found out of the items array. And because this items array always gets added in the same order that our menu items array exists, because this items array gets populated off of the menu items, the angles are always going to match up with where they are placed and where we have these existing. Because we're doing effectively like the inverse exact same math to create them and then to find them again here without needing to like save every angle and like compare that and like do weird stuff with all that. So that's the reason that this works. Now with all that, we have that function made, pick item by controller. So we put that in here now, and we just use the input value from our input action, and then we get our button out of that after all. And to that, we can just set the keyboard focus to that button. Do make sure that you're not an idiot like me and hook up this properly. Is nearly 0 2D. When it is false, pick item menu by controller instead of while it's true. Because if you're checking for it to be true, it's almost never going to be actually true. So yeah, that's a mistake that's easy to make. And you will see that if I open up the game now, I still cannot select anything, but you'll see why in a moment. If I stop playing the game, I get a bunch of warnings, and that is because the menu button is not focusable. So it should be focusable, so we go back into the menu button, click the topmost thing, the menu button itself, and here just look for focus, and enable is focusable. And then after that, we should be able to select our menu items just like that with the controller. And we have a dynamic radial menu. You can even update this during gameplay if you really wanted to, and everything should stay functional because it all relies on like pretty fundamental basic like trigonometry. So it's unlikely to break. If you, again, want the project files, links are down below in the description if you want to support the channel a little bit for more of this kind of content. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas, and my Cave Student tier supporters. Oiku.